Hey guys, my name is Arjun. I'm a robotics enthusiast. I love making robots. I'm currently pursuing 2 degrees, one in applied math and another in computer science. As part of the robotics at Maryland, I'm working on the software control systems for a robot dog project. In other words, I'm ensuring that the robot dog can do physical tasks like walking and navigation. It's been a pretty cool experience, so I thought I would share some of the work that I've done. Here's a kinda sus recording of me testing the first iteration of the robot dog software that I programmed. As you can see, the robot dog is fighting against external forces applied to it. While this was pretty cool to test out, there were still a lot of problems. First off, using a position-based control system is not very useful to control force, so I had to research a lot of alternative algorithms and eventually settled on an impedance controller for handling the dynamics of the robot. An important first step, however, is understanding the forward and inverse kinematics of the legs of the robot. So the idea is to treat each joint of the leg as a matrix transformation, and from there all we need to do is find the change of basis matrices that describe where the position of each joint is with respect to the origin. In this clip, I use RViz to simulate how the joints would behave given a variety of joint configurations. This is pretty useful later on when trying to understand the inverse kinematics of the robot, which is more difficult. Inverse kinematics is the process of figuring out how the joint should move in order for the end effector to get to a specific point in space. To solve this, I decided to use the gradient descent approach, which heavily relied on the analytical Jacobian. While this did have pretty good results, there were certain points in space where the algorithm struggled finding a solution for. Typically, we call these points singularities, and it stems from the fact that there are multiple solutions to reach those points. After some further optimizations and some more research, I decided to add a random walk, which would allow the leg to escape those singularities. A little bit of randomness allowed for the algorithm to converge to the correct point. It's pretty cool in my opinion to see the different solutions that it could find. There is obviously a lot that needs to be worked on, but we have at least a good foundation for moving on. Stick around for more.